Hello, bedtime thinkers, and welcome to the Bedtime Discoveries, a gentle corner of the night where science becomes soft, calm, and soothing. Tonight, let us rest together with a journey into one of humanity's oldest dreams, time travel. Time travel, the idea of moving forwards or backwards through time, has captured imaginations for centuries. From ancient myths to modern science fiction, the thought of stepping into the past or leaping into the far future has always fascinated us. But what does science itself really say about time travel? Tonight, we will softly wander through 10 gentle discoveries, each one bringing us closer to an understanding. Before we begin, I would love to know, where are you listening from tonight? And what time is it where you are? You can let me know in the comments. And if these calm bedtime explorations bring you comfort, please do consider liking this video and subscribing to the Bedtime Discoveries so you can drift off with me on many more gentle journeys to come. Time, it is something so ordinary and yet so deeply mysterious. We measure in hours, in days, in years. We glance at the clock to see whether it is morning or evening. We watch seasons change, leaves fall, and flowers bloom again. And we say to ourselves, time is passing. But what is it really? What is this invisible thread that carries us from the moment we are born until the day our story closes? We cannot see time. We cannot touch it, yet it shapes every heartbeat, every breath, every memory. Some of the greatest minds in history have wrestled with this question. The ancient Greeks wondered if time was like a river flowing ceaselessly forward. The philosopher St. Augustine once confessed, "I know what time is until someone asks you to explain it." And perhaps you have felt this too. We live in time constantly. Yet when we try to grasp it, it slips through our fingers like sand in an hourglass. Imagine yourself now, lying beneath the night sky, stars above you, silent and steady, the earth turning slowly, carrying you into tomorrow, the stars themselves glowing not in this moment but in the past. For the light that reaches us tonight may have left its star thousands, even millions of years ago. Already we see that time is not so simple. Already we glimpse its mystery. When we think of time, we often think of clocks, ticking steadily, second by second. But before clocks, before calendars, how did people know time? They watched the sun rise and set. They marked shadows stretching and then shrinking. They saw the moon wax and wane. They felt the coldness of winter give way to the warmth of spring. Time was felt in the rhythms of the earth itself, in the beating of the heart, in the patterns of breath, in the cycles of sleep and waking. And in this way, time has always been both scientific and personal, measured in numbers and lived in feelings. 1 hour may feel endless when we are waiting, or it may vanish in an instant when we are joyful. How strange it is that the same 60 minutes can feel so different depending on the mind that experiences them. As you lie here now, listening gently, notice how your own sense of time begins to soften. The minutes blur, the edges of thought loosen, and you are floating not in a rigid ticking of the clock, but in a soft current, like being carried by a gentle stream. Scientists today often describe time as a dimension. Just as we move through space left and right, forward and back, up and down, so too we move through time. Always, it seems forward, never backward. And yet, in the universe, time may be more flexible than it appears. But that is a thought we will explore later. For now, let us linger here in the simple mystery. Time as experience, time as memory, time as anticipation, a thread that stitches together every moment of your life. In your earliest memories, perhaps you recall being a child waiting for a holiday. The waiting felt endless, and yet now, looking back, those same years seem fleeting, as if time changes its rhythm when viewed in memory. This, too, is part of its mystery. There's an old saying, "The days are long, but the years are short." Perhaps you have felt that as well. On some days, time seems heavy, slow, and unyielding. But when we look back, the years feel as though they have vanished in a blink, as though time is not a steady march, but a trickster, always shifting its pace, depending on where we stand. Even our bodies, our clocks of their own. The heart beats in rhythm. The lungs expand and contract. Cells divide. The body grows and changes. Each of us is a living measure of time, a biological clock, slowly ticking toward the future. And so, as we rest here together, let us honor this gentle mystery. Time as something both vast and intimate, something that governs galaxies and also whispers softly in the quiet of your own breath. As we drift deeper into the mystery of time, let us imagine how people across history have tried to understand it. In the ancient world, civilizations built monuments to follow the sun's passage across the sky. The Egyptians raised tall obelisks, casting long shadows that moved slowly through the day. The Babylonians and Mayans studied the heavens carefully, building calendars of astonishing accuracy. To them, time was divine, written in the stars. Every sunrise, every eclipse, every turning of the seasons was a message from the cosmos. And yet, even with their wisdom, the deeper meaning of time remained hidden. For what is time itself? Is it a thing that flows like water in a river? Or is it simply the way we measure change, the shifting of moments from what was to what is? Philosophers, too, have wrestled with this riddle. The Greek thinker Heraclitus once said, "You cannot step into the same river twice." What he meant was, everything is always changing. The river flows, the world shifts, and so time carries us forward. But another philosopher, Parmenides, believed the opposite, that change is an illusion, and all of time exists at once. To him, past, present, and future are like pages in a book, all there, even if we read only one at a time. Which of them was right? Perhaps both, perhaps neither. Perhaps time holds secrets far beyond human words. Even today, our experience of time is not simple. Think of waiting for a train or waiting for a loved one to arrive. Every second seems heavy, stretched, almost painful. But think of sitting with friends, laughing, talking, sharing stories. Hours can pass, and it feels as though only minutes have slipped by. Time bends, not in the physics of clocks and gravity, but in the quiet theater of a mind. Psychologists study this. They find that when the mind is busy, delighted, engaged, we lose awareness of time's passing. But when we are bored or anxious, time slows, dragging its feet. Perhaps you've noticed how childhood summers seemed endless, while adult years seem to rush by like autumn leaves in the wind. Memory also changes our sense of time. The moments we remember most clearly often feel larger, fuller, longer, and those we forget vanish into the blur of time's river. In this way, our lives are stitched together, not only by what happens, but by what we remember and by what we forget. Now let's turn to science itself. Imagine for a moment the tiniest particle smaller than an atom, moving, vibrating, shifting in ways we can barely comprehend. For that particle, time may pass differently than it does for you or me. In fact, some particles decay at different rates depending on how fast they move. Already we see that time is not as steady as it first appears. Already we feel the mystery deepen. And yet, even as science explores time, we live it every day in simple ways. The morning sun that wakes us, the meals that divide the day, the slow turning of Earth itself, all of it measured in rhythms, all of it whispering softly that time is always moving forward. But is it always forward? Can time stand still? Can it flow backward? These questions will lead us further in our journey tonight. But before we wander there, let us pause and breathe. Here, in this moment, this single drop of time, you are safe, you are calm, you are carried by the quiet current of the universe. Think of a clock now, ticking steadily, its hands moving one step at a time. Tick-tock, tick-tock. Now imagine setting the clock down. Imagine the ticking fading into silence. And notice how time still moves, even without the sound. Moments continue. Breath continues. The world turns. Time flows on, whether we measure it or not. And in this way, the mystery of time becomes even deeper. Is time something real, existing outside of us? Or is it something our minds create to make sense of change? This question lingers as softly as the night itself. Close your eyes for a moment and imagine you are standing at the edge of an ancient desert. Before you, the sands stretch endlessly, dunes shifting with the wind, the sun rising and falling again and again. Each grain of sand seems so small, yet together they hold the story of countless ages. Time itself feels like that. Tiny, fragile moments forming the vast desert of existence. The universe, too, keeps its own clocks. Stars live and die. Galaxies form, merge, and dissolve. Cosmic cycles unfold over billions of years. From the first flash of the Big Bang to the slow cooling of the cosmos, time is written in the very fabric of space itself. Astronomers sometimes say that when we look at the night sky, we are looking into the past. Every star we see is not shining in this exact instant. Its light may have traveled thousands, even millions of years, before it touched our eyes. And so, the universe itself reminds us that the present is always mixed with the past, that what we see is never quite what is happening now. Even your own body carries deep records of time. Every cell holds traces of your history. Your bones remember the foods you ate as a child. Your skin bears the marks of sunlight and laughter and age. In your memories, moments long gone still live, still breathe. In this way, time is not only outside of us, it is within us. It is who we are. And yet, there is still more to the mystery. Think of dreams. In sleep, time bends in strange ways. A dream that seems to last hours may unfold in only minutes, or a single instant in waking life may expand into an entire story inside the mind's quiet theater. Time in dreams does not obey the same rules. It flows with feeling, with imagination, with something beyond the clock. Perhaps this reminds us that time has many faces, some scientific, some deeply personal. There is also the mystery of eternity. Religions and philosophies across the world have wondered whether time ever ends. Some imagine a circle where time repeats forever. Others see it as a line with a beginning and an end. Still others dream of eternity beyond time, where the ticking of clocks is no more, only endless being endless now. Science, too, raises profound questions. Is time fundamental, woven into the universe itself, or is it an illusion, emerging from the way matter moves and changes? Some physicists suggest that the equations describing reality do not even need time, that perhaps time is not a core ingredient, but a shadow, a byproduct. If this is true, then our entire experience of before and after may be something our minds create, a kind of story told so that life makes sense. And yet, even if time is an illusion, it is a powerful one, because for us it is real. We live it, we breathe it, we cannot escape it. The past lies behind us, the future waits ahead. And here we are in the present moment, listening, breathing, resting. As you listen now, notice how the present moment is already slipping away. Each second, each breath moves into memory. You cannot hold it. You cannot stop it. Time drifts forward gently, endlessly like the tide of an infinite ocean. And perhaps that is part of the beauty. If time never stopped, if every moment lasted forever, nothing could change. There would be no growth, no music, no movement, no life. It is because time flows that the flower blooms and fades, that laughter rises and falls, that night becomes morning, that you and I can meet here in this small, quiet moment. The mystery of time is not only something to solve, it is also something to cherish. Every second is a gift. Every moment is part of the story. And even though the river of time always moves forward, we can pause, we can breathe, we can rest on its banks and simply watch it flow. So now, dear dreamer, let yourself float in this mystery. Let go of clocks, of numbers, of worries, and imagine instead that you are lying on the shore of time itself, the current carrying you softly, effortlessly, into tomorrow, into all that is yet to come. Close your eyes for a moment and picture the world in the early 1900s. Horse-drawn carriages still rattled on cobblestone streets. Electric lights were just beginning to glow in cities. Trains and telegraphs connected nations. And science seemed steady, certain, and secure. In those days, people believed the universe was like a great clock, ticking smoothly and predictably. The laws of Isaac Newton had guided scientists for centuries. Time and space were thought of as fixed, solid, unchanging, absolute. A second here was a second everywhere. A meter here was a meter everywhere. The universe felt orderly, dependable, and knowable. And then along came a quiet young man, working in a patent office in Switzerland. His name, Albert Einstein. He was not a famous professor then, not a man with titles, laboratories, or wealth. He was simply a thinker, and he carried within him a restless imagination. Einstein often said that his most important tools were not books or instruments, but daydreams. He imagined strange scenarios. He asked questions no one else thought to ask. And slowly, those quiet daydreams began to change everything we thought we knew. One of his favorite thought experiments was this: what would happen if I chased a beam of light? If I ran beside it as fast as it traveled, what would I see? Would the wave of light stand still beside me, or would it keep rushing away? In asking this simple question, Einstein opened the door to one of the greatest scientific revolutions in history. He realized that the speed of light is not like anything else in the universe. No matter how fast you run or fly or move, the light will always race ahead of you at the same speed. It is constant, unchanging, absolute. But if the speed of light is absolute, then something else must be flexible. Something else must bend in order to make the universe balance. And that something was time and space themselves. Imagine space as a great, invisible fabric, soft, stretching, infinite. Now imagine time woven into that same fabric, together. They form what scientists call spacetime, not two separate things, but one single, flowing tapestry. Einstein's theory told us that when objects move very fast or sit in strong gravity, this fabric bends, twists, and stretches, and when it bends, time itself can change. This was a shocking idea for the world in 1905. It meant that time is not the same for everyone, that your clock and mine may tick at different speeds, depending on how we move and where we are. Einstein called this the theory of relativity, because it showed that measurements of time, space, and motion are all relative to the observer, no longer fixed, no longer absolute, but part of a flexible, dynamic universe. At first, many scientists resisted this idea. How could time itself be different for different people? How could space bend and stretch? It seemed too strange, too dreamy, almost impossible. And yet, experiment after experiment confirmed it. Clocks on speeding planes ran differently than clocks on the ground. Light bent around massive stars. The universe was behaving exactly as Einstein had described. And so, the young dreamer in the patent office changed the way humanity saw reality itself. Imagine for a moment if the world were as Einstein described, if time could bend, stretch, and slow, if your today could be someone else's tomorrow, if your second could be shorter or longer than mine. This is not fantasy. It is a universe we live in, and as we drift here tonight, we carry with us the gentle wonder that time and space are not rigid walls, but a soft, flowing fabric, a fabric that holds us all within its quiet embrace. Imagine again that great invisible fabric, space-time, a vast cosmic sheet, stretching in every direction, and upon this sheet, every star, every planet, every atom rests gently, like beads on a blanket. When something heavy rests upon the fabric bends, dips, curves around it. A planet curves space-time around itself. A star bends it even more deeply. And a black hole bends it so much that even light cannot escape its grasp. Einstein told us that this bending of space-time is what we feel as gravity, not a mysterious pulling force, as Newton once thought, but the gentle curve of the fabric, guiding objects along its slopes. Imagine rolling a marble across a stretched sheet. If the sheet is flat, the marble glides straight across. But place a heavy ball in the middle, and the marble curves, spirals, and circles around it. This is how Earth orbits the sun, not because the sun pulls us with an invisible rope, but because space-time itself is curved by the sun's mass, and Earth simply follows a curve. But Einstein's vision went further still. He showed that time is also part of this bending, that when space-time curves, time itself slows down. Think of a clock ticking far out in space, away from all gravity. Its hands sweep forward, steady, calm, unbothered. Now place another clock on Earth, where gravity presses strongly. That second clock will tick a little more slowly. Its second will stretch, just slightly compared to the first. This effect is tiny, almost invisible in daily life. But with precise instruments, it can be measured, and in the vastness of the cosmos, it becomes profound. Imagine standing at the edge of a massive star. The pull of gravity so strong that time itself crawls. Minutes stretch into hours, and an observer far away would see your clock ticking more slowly than their own. This slowing of time is called gravitational time dilation. It reminds us that time is not universal, not absolute, but gently shaped by the universe around it. And motion, too, plays a role. Einstein discovered that the faster you move, the slower your time flows. If a spaceship raced near the speed of light, the astronauts inside would feel time passing normally. They would eat, sleep, and laugh just as you do, but when they returned to Earth, they would find that more time had passed here than for them. Their clock, their bodies, their very lives would have run more slowly. This is not imagination. It is real. It has been tested with airplanes carrying atomic clocks. The clocks in motion ticked just a little slower than those on the ground, exactly as Einstein predicted. And so, relativity paints a universe where time is not a single steady river, but 1,000 streams, each flowing at its own pace, depending on speed and gravity. Your stream of time may be a little faster, mine a little slower, and yet within our own experiences, it always feels the same. Think of two friends separated across the cosmos, one living near a massive star, the other drifting in deep space, far from all gravity. Each lives their life, hour by hour, day by day. To each, time feels natural, ordinary, familiar, but when they finally meet again, they will discover their clocks no longer agree. Their journeys through time have not matched. Strange, isn't it? That the universe allows such differences. That time itself is personal, relative, elastic, and yet there is something deeply comforting in this. It means we are not trapped in a rigid, mechanical world, but instead we float in a living, breathing fabric. A universe that bends, stretches, and dances. A universe alive with softness. Einstein once said, "The distinction between past, present, and future is only a stubborn illusion." Perhaps he meant that if time can flow differently for each of us, then the boundaries we imagine are not as solid as they seem. Perhaps time is much larger, much stranger, much gentler than our minds can hold. And as you rest tonight, you too are drifting in this elastic fabric. Your seconds stretch and flow. Your body moves with Earth through space. And space-time itself cradles you softly, endlessly. Let us return now to the young Einstein in his quiet office. Stacks of papers on patents, ticking clocks on the wall, the world outside rushing with carriages and trains. But inside his mind, a universe was unfolding. Einstein's gift was not only mathematics, it was imagination. He saw the universe in pictures. He asked playful, childlike questions. He imagined himself riding beams of light. He imagined clocks on speeding trains. He imagined people floating in empty elevators, weightless. And from these quiet dreams came the seeds of relativity. One of his simplest images was of two lightning strikes. Imagine you are standing on a train platform. The train is at rest, and you see two bolts of lightning. One strikes the front of the train, the other strikes the back. To you, both flashes appear at the same time. Now imagine someone riding on the train. They are moving toward the front lightning bolt and away from the back one. For them, the front flash arrives sooner than the back one. Even though both happen together, which observer is correct? Einstein answered, both are correct, for time itself is relative to the observer. What you see as at the same time, another may see as different times. There is no universal now, only many nows woven into the fabric of the universe. This was a radical idea. It told us that simultaneity, things happening at once, is not absolute. It depends on where you stand and how you move. Time, space, and even the meaning of now are flexible, personal, and relative. And yet, within this strangeness lies great beauty, because relativity unites everything into one grand design. Space-time, a vast, interconnected web. Every motion, every moment stitched together by invisible threads. The theory also reveals something extraordinary about energy and matter, that they are not separate things, but two forms of the same essence. This was expressed in Einstein's most famous equation, E equals mc superscript 2. Energy equals mass times the speed of light squared. A small amount of matter can become a vast amount of energy, and energy, too, can become matter. Though this part of relativity may seem distant from time, it shows us how deeply woven the universe is. Nothing is fixed, nothing is rigid. All is transformation, flow, and relativity. Relativity also changed the way we think of the cosmos itself. It predicted that the universe could not be static, that space and time together must expand or contract. Years later, astronomers discovered that galaxies are indeed rushing away from one another. The universe is expanding, just as Einstein's equations whispered. So we see relativity as not only about clocks and trains. It is about the shape of the entire cosmos. It tells us how stars burn, how black holes form, how time stretches across the universe. And yet, even with all this, relativity has a strangely human side, for it began with simple daydreams, a man wondering what light looked like, a mind playing with images, a heart curious about the deep mystery of existence. It reminds us that even the greatest discoveries often begin in quiet moments, moments of wonder, moments of imagination, moments not so different from this one. As you rest, listening softly, perhaps you too can drift into daydreams. And who knows what worlds may unfold there? And so, as we complete this gentle keynote, let us carry with us a simple truth. Einstein showed us that the universe is not rigid, mechanical, or absolute. It is flexible, living, flowing. Space and time are threads in one great fabric. And within that fabric, each of us moves, breathes, and dreams. Tonight, as you drift into sleep, remember that you too are part of this grand design. The fabric of space-time cradles you. Time flows around you, through you, within you, and every heartbeat, every breath is woven into the quiet rhythm of the cosmos. Imagine drifting high above the earth, beyond the clouds, beyond the blue sky, into the velvet dark of space. Around you, stars glitter silently. Earth turns slowly beneath your feet, and the quiet is so deep, so endless, that it feels as though time itself is holding its breath. Out here, far from the familiar ticking of clocks on Earth, time begins to behave in unusual ways. Einstein's theory of relativity told us that time does not flow at the same pace everywhere. It can stretch or shrink depending on speed and gravity. This bending of time is called time dilation, and nowhere is it more profound than in the vast expanse of space. Let us begin with speed. On Earth, most of us move slowly compared to the speed of light. cars, planes, even rockets are nothing next to light, which rushes around the universe at 300,000 kilometers per second. But when an object begins to move faster and faster, closer and closer to this cosmic speed limit, time for that object begins to slow down compared to everything else. Imagine two astronauts, twin sisters, let's call them Mira and Alara. Mira remains on Earth, walking her garden paths, watching seasons change. Alara boards a spacecraft and journeys into the cosmos. Her ship accelerates to a speed near the speed of light. Inside, she feels normal. Her heart beats. Her meals pass. Her days seem ordinary. But back on Earth, the years begin to fly past. When Alara finally returns, she may have aged only a few short years, while her sister Mira has grown older by decades. This is no mere fantasy. It is the real effect of time dilation, proven not only in equations, but in experiments. Scientists have flown atomic clocks aboard airplanes and satellites, and found that those clocks tick more slowly than identical clocks on the ground. The difference is tiny but measurable, a whisper from the universe, telling us that Einstein was right, and the effect grows stronger the faster we travel. If a ship could somehow move at 99% the speed of light, time for its passengers would crawl compared to those left behind. They might cross the galaxy in what feels like a single lifetime, only to return and find that thousands, even millions of years have passed on Earth. This is one way we could one day travel into the future, not by building a magical machine, but by harnessing the simple laws of motion and letting speed itself carry us forward in time. But speed is not the only player in this cosmic story. Gravity, too, can slow time. The stronger the gravity, the slower time flows. On Earth, we already live in a gentle version of this. Clocks at the top of a mountain tick a little faster than clocks at sea level because they are farther from Earth's center of gravity. The difference is impossibly small for us to feel, but our satellites and GPS systems must account for it, or else our maps would be wildly wrong. Now, imagine standing near something far more powerful than Earth. Imagine standing at the edge of a massive star, or orbiting close to a black hole. Here, gravity bends spacetime so intensely that time itself stretches like soft clay. Minutes near the black hole could equal years far away. This strange truth was beautifully imagined in the film Interstellar, where astronauts landed on a planet close to a black hole. For every hour they spent there, 7 years passed for those who remained far away. Though told in fiction, this idea was born from Einstein's equations and reflects the real mysteries of time dilation. So, in the vastness of space, time becomes fluid, flexible, alive. Speed and gravity shape its flow, and astronauts become travelers not only through distance, but through time itself. As you listen now, let yourself drift into the vision of stars, of ships moving at near light speed, of planets circling black holes, where time trickles like honey, and notice how small our everyday seconds begin to feel. Each tick of the clock is only one possibility among countless streams of time, and in this gentle truth there is wonder. For time, it seems, is not a cage, but a river with many currents, and in the silence of the cosmos, it whispers softly that there's more to existence than we ever imagined. Imagine the simplest of human inventions, the clock, ticking steadily, marking the rhythm of our days. We trust it to be steady, reliable, universal. But in truth, a clock does not measure time itself. It only reflects the motion of something else. A pendulum swinging, a crystal vibrating, or in the case of the most precise clocks, atoms shifting in tiny, invisible ways. And when the conditions of motion or gravity change, so too does the clock's rhythm. This is where the mystery of time dilation becomes something we can measure, not just imagine. Scientists once placed highly sensitive atomic clocks on airplanes circling the globe. One set remained on the ground. The other soared through the sky. When the experiment was complete and the clocks were compared, they did not agree. The airborne clocks had lost a little time. Just as Einstein predicted, this experiment, repeated many times since, shows us that time dilation is not only a theory, it is a quiet, measurable truth of our universe. And it grows more fascinating when we look to the stars. Think of the International Space Station, a home drifting above Earth, circling our planet at more than 27,000 kilometers per hour. Inside, astronauts work, eat, sleep, and laugh. Their clocks tick, their hearts beat. But compared to people on Earth, time flows just slightly differently for them. Aboard the station, time passes a little slower because of the high speed. Yet at the same time, because they are farther from Earth's gravity than we are, time also passes a little faster. The two effects compete, and the balance is delicate. After months in orbit, astronauts return to Earth having experienced time, just a tiny fraction differently from those who remained on the ground. The difference may be only milliseconds, but it is real, it is measurable, and it tells us something profound, that every journey into space is also a tiny journey into the future. Now let us extend this thought experiment further. Imagine a ship that could fly not just thousands of kilometers per hour, but millions. Imagine reaching 99% of the speed of light. On board, the crew might live their days normally, but their clocks would slow drastically compared to those on Earth. A single year on their ship could equal decades or even centuries on Earth. They would become travelers not only through distance, but through the river of time itself, returning to a world they scarcely recognize. A future where cities, languages, and people have changed, all while they themselves feel only a year or two older. This vision is not fantasy. It is a logical consequence of Einstein's equations. The closer to light speed you go, the more time stretches for you. And though we do not yet have ships capable of such travel, the laws of the universe suggest it is possible. And then there is gravity's hold on time. Imagine two identical clocks, one placed on Earth's surface, the other carried high into orbit or to the top of a mountain. The clock closer to Earth's mass runs just a little slower. It is caught in the deep curve of spacetime that gravity creates, while the one farther away ticks a little faster, freed from some of that pull. We see this effect clearly in the technology we use every day. Our GPS satellites, circling high above Earth, rely on atomic clocks. If we ignored relativity, their time would slowly drift out of sync with ours, and within hours, our navigation systems would fail. Our maps would be wrong. Our journeys would lead us astray. It is only because we account for time dilation that your phone can tell you where you are, down to a few meters, anywhere on Earth. So, you see, relativity is not only a grand cosmic truth, it is woven into the ordinary fabric of modern life. Every time you check a map, every time a plane lands safely, every time satellites whisper across the sky, Einstein's time dilation quietly shapes your world. And this brings us to a beautiful reflection. Time is not a single rhythm shared by all. It is a chorus of rhythms, some fast, some slow, all shaped by the great cosmic dance of motion and gravity. When you look up at the stars tonight, remember that each star, each planet, each galaxy is carrying its own flow of time. 1,000 clocks, 1,000 streams, all part of the great river of the cosmos. And you, too, are part of that river. Your seconds and minutes are yours alone. Your heartbeat marks a rhythm unique to you. And though others may flow differently, faster or slower, together we all drift in the gentle current of space-time. Close your eyes for a moment and imagine yourself standing at a train station in the far future. Above you, the sky is alive with starships, some moving slowly, others rushing at near the speed of light, and each one carries a different rhythm of time within it. For the people waiting with you on the platform, time is flowing at its normal pace. Seconds, minutes, and hours drift by, but for those aboard the starship streaking past, their clocks tick more slowly. And for those drifting near the pull of some massive star or black hole, time crawls even more. It is as if the universe is a great symphony, with countless instruments, each playing its own tempo, yet together creating a cosmic harmony. This is the heart of time dilation. That time itself is not universal. It is personal, local, shaped by where you are and how you move. Now, you might wonder, what would it feel like to live in such different streams of time? The truth is, you would never notice it yourself. Inside your own frame of reference, life feels perfectly normal. Your heart beats steadily. Your meals come at the right time. You do not feel slower or faster. You are simply you, flowing at the rhythm of your own clock. But compared to someone else, far away in space, your life might be unfolding at a different pace altogether. And when you meet again, the difference becomes startling. This is why the famous twin paradox fascinates us so deeply. One twin stays on Earth. The other travels on a near light speed journey. When they reunite, one has aged far more than the other. Though their memories feel complete, though their lives feel natural, their timelines are no longer aligned. It is not science fiction. It is the natural consequence of motion and gravity. The paradox is only strange because our minds are so used to thinking of time as a single, shared river. But the universe shows us that there are countless streams branching, bending, rejoining. And perhaps there is something comforting in this thought, that each of us, in a way, carries our own time with us, our own rhythm, our own pace, a deeply personal thread in the fabric of space-time. Consider what this means for journeys beyond Earth. If one day humanity sends explorers to distant stars, they may return to a planet centuries older than when they left. Generations may have passed. Nations may have risen and fallen. But the travelers themselves will feel they've been gone only a handful of years. Such voyages would not only be adventures of distance, they would be adventures of time, journeys into futures unseen. Our descendants may one day meet travelers returning from the stars, people who set out in the age of their great-great-grandparents, and yet arrive looking young, alive, almost untouched by the passing centuries. What a strange and beautiful reunion that would be, to meet someone whose childhood belonged to a world long gone, yet who walks among you as if only a short time has passed. In this sense, time dilation is not only a scientific curiosity, It is a bridge between eras, a reminder that time is not fixed, but alive, flexible, and deeply mysterious. Even here on Earth, we live with faint whispers of this truth. A mountain clock and a sea level clock already disagree. An astronaut and a farmer on Earth already drift apart by milliseconds. Tiny differences, invisible to us, yet proof that our universe is never as simple as it seems. And maybe there is poetry in knowing that time is not a single law, rigid and absolute, but a gentle fabric stretched and shaped by gravity and motion. It makes the universe feel more alive, more mysterious, more full of wonder. Now let's reflect quietly. If time can bend and stretch, if it can move differently for each of us, then perhaps, in a way, we are all time travelers already. Each moment we live is unique to us. Each heartbeat, each breath is a tiny journey in our own personal stream of time. And though our flows may be different, we meet one another along the way, sharing moments, exchanging stories, touching lives, before drifting onward again, carried gently in our separate currents. So tonight, as you listen and as you rest, perhaps you can feel yourself floating in that current, the seconds stretching, soft and unhurried, your mind drifting, your body calm, as if you too are sailing through the vast river of spacetime, where every dream, every thought is part of your own quiet journey. And in this there is peace, for time, in all its strangeness, still carries us forward, gently, steadily, like a cosmic tide, toward futures yet unknown. Imagine a place in the universe, so strange, so powerful, that even light itself cannot escape. A place where gravity is so strong that space and time are pulled, stretched, and twisted into shapes almost beyond imagination. These are black holes, dark hearts of the cosmos, born when massive stars collapse under their own weight, falling inward, deeper and deeper, until all of their matter is compressed into a single point, infinitely dense. Around this point, space bends so steeply that not even a beam of light can climb out. This invisible boundary is called the event horizon. Once crossed, there is no return. But what makes black holes even more fascinating is not only their darkness, but their connection with time. For near a black hole, time does not flow as it does here on Earth. It slows, stretches, bends, so deeply that the difference can feel almost impossible to imagine. Let us picture an astronaut slowly approaching a black hole. From her point of view, her clock ticks normally. Her heartbeat, her breaths, her thoughts all unfold naturally. But if we were watching her from far away, we would see her movements slow, slower and slower still. As she nears the event horizon, time for her seems to almost stop. She freezes, suspended at the edge of forever. To her, time feels unchanged. To us, she appears locked in place, a living statue at the threshold of darkness. This is the magic and the terror of gravity's hold on time. Black holes are not just objects of mass. They are wells of spacetime itself, deep pits in the fabric of a universe. The closer you fall toward them, the more your own time is stretched compared to the outside world. In this sense, black holes are like natural time machines. They create conditions where hours for one person can equal centuries for another. The film Interstellar gave us a glimpse of this. Astronauts landed on a planet orbiting close to a black hole, and for every single hour they spent there, 7 years pass for those who remain far away. Though told through cinema, this idea came directly from Einstein's relativity. It is one of the most haunting truths in all of physics. Now let us slow down and imagine the scene together. The black hole hangs before you, not as a shining star, but as a circle of endless night. Around it, matter swirls in bright ribbons. Gas and dust pulled inward, glowing with unimaginable heat. It is as if the universe itself is painting a halo of light around a hole of nothingness. As you drift closer, your ship trembles, gravity pulls harder, stronger, and your clock begins to slow compared to those left behind. If you return, you might find that years, decades, even centuries have passed for them, while for you, only days or weeks have slipped by. This is the breathtaking, eerie effect of black holes on time. They remind us that time is not absolute. It is part of the fabric of the cosmos. And in the most extreme places, that fabric can be stretched almost to breaking, and perhaps there is something humbling in this, that time itself, which feels so steady to us here on Earth, is fragile, flexible, vulnerable to the pull of gravity. When you gaze at the night sky and wonder about the mysteries beyond, remember that hidden in the darkness are places where time itself whispers at a different pace. And tonight, as you listen softly, you too can imagine yourself drifting near that event horizon, feeling the seconds stretch like honey, feeling the universe slow to silence, as if you have stepped outside of ordinary time. Imagine again the black hole before you, a silent, dark sphere, surrounded by a halo of light, a glowing whirlpool of stars, dust and gas, all spiraling inward, pulled by its irresistible gravity. To understand how black holes affect time, let us take the perspective of two people. One of them, let us call her Aria, ventures close to the black hole in her spacecraft. The other, her friend Solon, remains far away, watching from a safe distance. For Aria, everything feels normal inside her ship. Her heartbeat is steady, her thoughts flow, her clock ticks quietly. But to Solon, watching from afar, Aria seems to slow down. Every movement, every wave of her hand, every blink of her eyes stretches out, longer and longer, as she approaches the event horizon, the edge of no return. Solon sees her slow, almost to stillness, frozen in time at the border of darkness. Her ship hovers there, unmoving, though in reality she continues her fall. This is one of the strangest truths of black holes. From the outside, time near the horizon seems to stop. But for the traveler, time feels completely ordinary. They continue forward, unaware how distorted their journey looks to others. This idea is not only theory. It is built into Einstein's mathematics of spacetime, and it has been supported by countless studies of how gravity bends light and time. Now let us pause and think more deeply about what this means. A black hole is not simply a place. It is a region where the very rules of reality are bent, where space curves inward and time itself stretches, until our everyday sense of cause and effect begins to blur. The closer you drift toward the black hole, the stronger the pull, and the slower your time runs compared to the rest of the universe. An hour for you might equal years or centuries. Outside, it is as if the black hole guards a doorway to the future, and anyone who lingers near it steps through that doorway without ever realizing. But here is the most haunting part. Once you cross the event horizon, there is no way back. Inside, all paths lead inward. Space itself curves so completely that every direction takes you closer to the center, and at that center lies a singularity, a place of infinite density, where our understanding of physics breaks down. What happens there, no one knows. It is a silence in our knowledge, a place where the equations end and mystery begins. Some scientists imagine that time itself comes to an end at the singularity. Others wonder if new laws of physics, hidden in the quantum world, might appear there. Perhaps even other universes could be born, budding from the heart of black holes. For now, these remain dreams and speculations, whispers at the edge of human understanding. But what we do know is that black holes reveal something profound, that time, so familiar and ordinary to us, is fragile, flexible, and deeply tied to the shape of space. To help us picture this, scientists often compare spacetime to a fabric. Imagine a heavy ball placed on a stretched sheet. The ball makes the fabric curve downward. If you roll a smaller ball nearby, it will spiral inward toward the heavy one. In a similar way, massive objects curve space-time and pull other objects in. But a black hole is like a weight so great that it doesn't just curve the sheet, it stretches it downward without end, so steep, so deep, that nothing, not even light, can escape its pull. And within this infinite curve, time itself slows to near stillness. The ticking of clocks, the beating of hearts, the passing of moments, all become drawn out, stretched, distorted. It is as if the black hole whispers, "Here, time has no hurry. Here, eternity waits at the edge of every second." Now, imagine again Arya, the traveler near the event horizon. To her, only a few hours may have passed, but when she finally escapes, if she could, she would return to a universe unimaginably older. Perhaps the Earth she once knew is gone, its oceans dry, its mountains worn, while she herself has aged only a small amount. Black holes, in this way, are like cosmic time machines. They do not let us travel back to the past, but they carry us forward into distant futures, simply by bending time around their gravity. And though this may sound like science fiction, it is one of the most grounded truths in physics. It is not imagination alone. It is written into the equations that describe our universe. When you look at the night sky and imagine the stars hidden in its velvet darkness, remember that somewhere out there, black holes are silently stretching time, creating pockets of the universe, where moments linger almost forever. And perhaps as you drift into dreams tonight, you can imagine yourself floating near such a place, not afraid, not hurried, but simply resting as time itself slows into a calm, endless stillness. Let us return to the thought of black holes as not only destroyers, but as mysterious guardians of time. For centuries, humans have looked at the night sky with wonder, but black holes remind us that the universe is not only vast, it is also deeply strange, full of places where the rules we trust bend into shapes we barely understand. And perhaps the most haunting truth is how these dark objects twist time itself. Imagine again two friends separated by fate. One drifts near a black hole, the other remains far away. When they meet again, if they ever could, they would find their lives utterly out of sync. One has aged slowly, the other quickly. One carries only days of memory, the other carries decades. Both are correct, both are true, for each has lived in their own personal flow of time. This strange difference does not mean the universe is broken. It means the universe is richer, more layered than we ever thought. Now, let us step into the realm of speculation. Scientists often wonder, could black holes be more than just ends? Could they be beginnings as well? Some theories suggest that deep within, past the singularity, might lie a bridge to another region of space-time, a hidden corridor, a passageway, a doorway, leading perhaps to another universe altogether. These are called wormholes, theoretical cousins of black holes, and though they remain unproven, they offer a tantalizing thought that perhaps, within the heart of darkness, there are hidden gateways of light. If such gateways exist, then black holes may not only stretch time, they may connect it, linking one region of space-time to another, like tunnels between worlds, perhaps even between past and future. For now, this remains a dream of mathematics, but it shows us how black holes open our minds, not only to what we know, but to what may yet be discovered. And even without wormholes, black holes are already time machines of a kind. They carry us forward, not backward, into futures far beyond our reach. They remind us that time is not absolute. It is a fabric pulled and stretched by mass and gravity. Let us think for a moment of our own lives. Here on Earth, time feels steady. Seconds tick, hours pass, days unfold. But in truth, even here, time flows differently in subtle ways. At the top of mountains, clocks run faster. At the bottom of oceans, they run slower. Tiny differences, invisible to us, but real and measurable. Black holes take this quiet truth and magnify it into something astonishing. They show us that time is fragile, delicate, flexible, and that the universe is far stranger than our everyday senses reveal. And perhaps there is comfort in this mystery, because if time can bend, if it can flow differently depending on where you stand, then perhaps our experience of it, too, is not fixed. Perhaps memory, dream, and imagination are also ways of stretching time, ways of touching eternity, even here, even now. As you rest tonight, let your thoughts drift toward these dark, silent giants. They are not monsters to be feared, but mysteries to be honored. They hold the deepest secrets of gravity, space, and time. And though we may never step across their event horizons, they still whisper to us from afar, teaching us that the universe is softer, stranger, and more fluid than our ordinary minds can grasp. Picture yourself now, drifting near one of these cosmic wonders. You feel no fear, only calm. Your ship floats in the stillness, your heart steady. Outside, the stars seem to linger, their light stretched, slowed, curved by gravity. Time itself feels unhurried, gentle, eternal, as if the black hole has wrapped you in its quiet embrace. And when you finally drift away, carried back into open space, you carry with you the reminder that time is not rigid. It is alive, flowing, mysterious, and that the universe, in all its beauty, is far more wondrous than we can ever fully know. Close your eyes for a moment and picture two twins, alike in every way, born together, raised together, sharing the same laughter, the same childhood memories. Now imagine that one day they stand at a crossroads. One remains here on Earth, grounded beneath the skies they both grew up under. The other boards a spacecraft, sleek and silent, ready to voyage into the great expanse of space. This simple thought experiment is called the twin paradox. And though it sounds like a story, it is one of the most fascinating and real predictions of Einstein's theory of relativity. The paradox is not about contradiction, but about surprise. It reveals how time itself behaves differently depending on where you are and how you move. Let's walk slowly into this mystery together. The twin who stays behind lives their life on Earth. Days flow into nights, weeks into months, years into decades. They see seasons come and go. They watch flowers bloom and fade, oceans rise and fall. Children grow into adults. Their clock ticks at the steady rhythm of our planet's heartbeat. But the traveling twin feels a very different rhythm. As their spacecraft accelerates to a great speed, near the speed of light, something strange happens. From their perspective inside the ship, life feels normal. Their heartbeat, their breathing, their thoughts, their small daily actions all flow just as they always did. But compared to the twin on Earth, their time has slowed. The faster they move through space, the slower they move through time. This is not imagination, not a trick of the mind. It is a real effect written into the fabric of reality. Now imagine decades have passed. The traveling twin finally returns to Earth. They step out of their ship, expecting to find their sibling much as they left them. But what they discover is astonishing. The earthbound twin has aged perhaps 40, 50, or 60 years. They are older now, their hair touched with silver, their face marked by time's gentle hand. But the traveling twin? They may have aged only a few years, or even just months. Two people who once shared the same birthday now stand face to face, their ages no longer aligned. They are twins still, but no longer the same in time. This is the essence of the twin paradox. It is not a fantasy. It is a consequence of Einstein's special relativity, tested and confirmed by experiments with high-speed particles, and even with precise atomic clocks flown aboard airplanes and satellites. Time is not absolute. It bends and shifts with motion. And when one twin moves swiftly through the universe, they carry with them a slower clock, compared to the one who remained behind. But why do we call it a paradox? At first glance, the situation seems symmetrical. From the traveler's view, couldn't they say the Earth was moving while they themselves were at rest? Why wouldn't that mean the earthbound twin should be younger when they meet again? Here is where the subtlety lies. The traveling twin experiences acceleration. They must fire their engines, turn their ship, and return to Earth. That moment of acceleration breaks the symmetry. It makes their journey different from the one who stayed at rest. And so, when they reunite, the difference in aging is real, measurable, undeniable. Let us soften the thought experiment with a gentler vision. Imagine the twins sitting together again after their reunion. One older, one younger. They share stories, laugh at old memories, marvel at the strangeness of what has happened. The older twin speaks of the decades that unfolded on Earth, the lives lived, the generations passed, while the younger twin carries only the freshness of a much shorter span. It is as though the travelers stepped into a doorway to the future. They leapt across time, not by magic, but by motion. And though they cannot return to the past, they have glimpsed how fragile the flow of time truly is. The twin paradox is more than a curiosity. It teaches us that our everyday sense of time as universal, shared, and constant is only an illusion. In truth, each of us carries our own rhythm of time, a personal flow, shaped by where we are, how we move, and what forces surround us. Here on Earth, the differences are so small we rarely notice them. But in the vastness of space, under the weight of immense speeds and gravity, these differences become profound, reshaping the very meaning of aging and experience. The twin paradox whispers to us that time is not a rigid line, but a living fabric, stretching, flexing, and flowing differently for each observer. And in its gentle, puzzling way. It invites us to wonder what else we might discover as we continue our journey into the mysteries of time and space. When we first hear the tale of the twins, it feels like a riddle, a puzzle left unsolved. How could two people born at the same moment end up in such different ages? It feels almost like magic, and yet it is not magic. It is a quiet poetry of physics, written into the fabric of space-time itself. To understand, we must return to Einstein. More than a century ago, he told us something strange and wonderful. The speed of light is the same for everyone, whether you run toward it or away from it. No matter how fast you move, light will always greet you at the same unchanging pace. But if the speed of light is fixed, then something else must bend, and that something is time and space. Time slows down for those who move quickly. Space contracts in the direction of their motion. This dance of slowing time and shrinking space keeps the speed of light steady and keeps the universe in harmony. The twin who journeys through the stars lives inside this bending of time. Their clock ticks slower, not because it is broken, not because it lags, but because the universe itself insists on it. At first, this might sound too strange to believe, but experiments again and again have shown it to be true. Scientists have taken atomic clocks, devices so precise that they lose less than a second over millions of years, and flown them aboard airplanes, circling the Earth. When the clocks return, they no longer agree with their twins left on the ground. The difference is tiny, measured in billionths of a second, but it is real, and it is exactly what relativity predicts. In particle accelerators, physicists see the same effect. Tiny particles called muons normally vanish in a fraction of a second, but when they race near the speed of light, their lifespans stretch. They live longer than they should, because time itself slows for them. And in orbit around Earth, satellites of the global positioning system must correct for time dilation every moment. Without those corrections, our GPS devices would fail within minutes. Our maps would twist, our directions would falter, but because scientists account for relativity, our world stays aligned. What once seemed like a paradox is now part of the daily heartbeat of technology. So let us return to our two siblings. One remained on Earth, aging with the steady rhythm of the planet. The other traveled at immense speed, aging more slowly. Why does the traveler end up younger? Because their path through space-time is different. Both twins move forward through time, of course, but the traveling twins spend some of their journey trading time for space. By moving so quickly through the universe, they move more gently through time. It is as though each of us carries a candle of moments. The one who stays still burns through their candle at the normal pace. Flame steady, wax melting slowly. But the one who rushes through space allows their flame to stretch, to burn more slowly, so that when they return, more wax remains, more youth is left. And yet, some still ask, but can't the traveler say the Earth was moving? Why shouldn't the earthbound twin be younger instead? The answer lies in the details. The twin on Earth never changes direction. They remain in one steady frame of motion. The traveler, however, must accelerate, slowing their ship, turning, firing engines, reversing course to return home. This acceleration is what breaks the symmetry. It makes their experience different, anchoring the difference in aging. So the paradox is not a contradiction at all. It is a window into how motion, speed, and gravity entwine with time. The twin paradox reminds us that time is not a single, universal river. It is more like a web of many streams, winding at different speeds. depending on where you stand, how you move, and what forces you feel. For the earthbound twin, life flows steadily, familiarly. For the traveler, life flows slowly, stretched across the stars. Both are correct. Each lives in their own truth of time. And when they meet again, their truths collide, and the universe reveals its quiet strangeness. Now, let us soften the science with imagination. Picture the reunion once more. The older twin reaches out with wrinkled hands, eyes shining with decades of stories. The younger twins stand with the freshness of youth, though they too have traveled a lifetime of distance. In that embrace, science and love entwine. The laws of relativity are not cold or distant. They are written into the human heart, into the way we tell stories, into the way we wonder about life's mysteries. The twin paradox is not only a thought experiment, it is also a meditation on time, aging, and the fleeting beauty of our lives. For if time can stretch and bend under the stars, perhaps our own experiences of memory and dream are also gentle forms of time travel. As you drift tonight, let this thought linger. Each breath you take, each heartbeat, is your own unique rhythm of time. It may not match anyone else's perfectly, but it is yours, a private current flowing quietly through the vast ocean of the universe. The story of the twins, one staying on Earth, the other voyaging into the stars, is more than a scientific curiosity. It is also a mirror reflecting back to us deeper truths about the universe and about ourselves. The first lesson is simple, yet profound. Time is relative. Not relative in the sense of vague or uncertain, but relative in the sense that it flows differently for different observers. The twin who travels fast moves into a slower current of time. The twin who remains on Earth drifts with the planet's steady rhythm. Both journeys are valid. Both are real. Both are deeply personal. This invites us to imagine life itself in a new way. Our days may feel ordinary, our clocks ticking evenly, our years unfolding in familiar cycles. But beneath that surface lies a deeper truth. Time is not one universal river. It is countless streams, winding differently for each traveler in the cosmos. The paradox also reminds us that motion changes how we experience reality. The faster we go, the slower we age. The deeper we sink into gravity's pull, the more time bends. Though we cannot yet travel at near light speeds, we already see this truth in our world. High above Earth, astronauts on the International Space Station age just a tiny bit slower than those of us on the ground. Not enough to notice, but measurable. It means that even now among us, there are small differences in the flow of time, invisible threads of relativity woven silently through our lives. Now imagine yourself in the place of the twins. Would you choose to stay, to live a life steady and full upon the earth? Or would you choose to voyage, to see the stars up close, to stretch your time, but return to find the world older than you remember? There is no right answer. Both choices carry beauty, both carry loss. The paradox reflects our human experience. That time is always a balance between presence and change, between the moments we live and the moments we miss. The twin who stayed has decades of Earth stories, sunsets, laughter, friendships, seasons. The twin who traveled has fewer years, but carries the wonder of the stars. Together, they remind us that life is not measured only in length, but also in depth, in experience, in meaning. Einstein's theory is mathematics, yes, but within it lies poetry. It tells us that speed and gravity are not just physical forces. They are also sculptors of time. They stretch and shape the very moments of our lives. And so, the twin paradox is not a trick. It is a window. It shows us that the universe is stranger and softer than it seems. It whispers that reality is flexible, that the future is not fixed, and that time is not as rigid as our clocks pretend. Close your eyes and imagine you are the traveling twin. Your ship hums softly as it glides near the speed of light. Outside the window, stars streak into long threads of light, their patterns bending as you pass. You feel calm, steady, timeless. Your body ages slowly, your heartbeat quiet. When you finally return, you find a changed earth. Children you once knew are grown. Cities are different. The world has turned forward without you. And yet, you stand there, carrying both youth and wonder. You have not lost time. You have lived it differently. The twin paradox may seem distant, belonging to astronauts and physicists, but it offers lessons for each of us. It reminds us to treasure the time we share with others. For while our clocks may tick in unison, our experiences are never exactly the same. It teaches us that time is precious, flexible, and deeply personal. And it invites us to let go of the illusion of rigidity, to see time not as a strict ruler, but as a gentle river, flowing differently for each of us. Even in daily life, we feel echoes of this. When we are joyful, time seems a rush. When we are waiting, time lingers heavy. When we dream, whole lifetimes that unfold in a few moments of sleep. Perhaps this, too, is the poetry of relativity, our inner worlds mirroring the flexibility of the cosmos itself. The twin paradox does not break reality. It reveals it. It shows us that the universe is built not on rigid walls, but on flexible threads, woven together into a vast and living tapestry. And though the twin story is often told as a scientific puzzle, it is also a bedtime story for the soul, a reminder that we are travelers, all of us, drifting through space and time, each on our own winding path. And someday, perhaps when humans voyage to distant stars, the twin paradox will not only be a thought experiment, it will be lived reality. Generations will age differently. Travelers will return to find futures waiting for them. And humanity will carry forward its dance with time into the cosmos. As you rest tonight, let this gentle truth soothe you. You are part of time's great mystery. Your moments are yours alone, flowing at your own rhythm. And just as the twins remind us, time is not a single path, but many threads woven together into quiet beauty of existence. When we imagine the future of time travel, we step into a world that hovers gently between science and imagination. It is not only a question of physics, but also of hope, curiosity, and a deep human desire to explore what lies beyond the horizon. For thousands of years, people have dreamed of escaping the present moment. Stories of prophets, seers, and time walkers whisper through every culture. Ancient myths told of gods who could slip into the past or step ahead into the future. And today, our films, novels, and dreams continue this tradition, painting visions of people stepping into strange machines, turning dials, and leaping across centuries. But what does science say? As we look toward tomorrow, how close are we to making these dreams real? Time travel is not merely fantasy. Even now, in small, delicate ways, it already exists. Astronauts who spend months aboard the International Space Station age a fraction of a second less than those who remain on Earth. Particles and accelerators live longer when they move near the speed of light. Satellites must constantly correct their clocks to stay in harmony with Earth. These are tiny examples of forward time travel, happening every day. They are glimpses of what the future might hold. If we learn to harness the deeper truths of relativity and quantum mechanics. So when we speak of the future of time travel, We are not speaking of pure fantasy. We are asking, how far can we push these effects? Could one day a human being leap not just seconds ahead, but decades or centuries? To imagine this, picture the spacecraft of the future. Perhaps one day, humanity will build engines powerful enough to push ships close to the speed of light. Those who travel aboard such vessels will return younger than those who remain. This is not science fiction. It is already written in Einstein's equations. It is simply a matter of technology, of reaching the speeds that nature demands. And beyond speed, there may be other paths. Some scientists imagine using gravity itself, black holes, or artificial structures as tools to bend time. Perhaps with future engineering, humans could create controlled distortions of spacetime, gentle pockets where time flows differently, doorways to the future crafted by our own hands. But along with possibility comes responsibility. If humans could travel through time, even forward only, what would it mean for our societies? Imagine a traveler who leaves in the year 2200, only to return in the year 2700, having aged just a few years. They would step into a world utterly changed. New languages, new cultures, new technologies, perhaps even new forms of life itself. Would they feel like a guest or a stranger? Would time travel be a gift of wonder or a burden of disconnection? And if humanity ever found a way to travel backward, though science today says this may be impossible, we would face even greater questions. Would we risk altering history? Would we see people try to prevent mistakes, or to seize power, or to reshape the world for their own purposes? This is the great puzzle of causality, the fragile thread of cause and effect that holds our universe together. For now, time travel remains more of a dream than a destination. But dreams are powerful. They drive scientists to explore, to question, to build. And as we gaze into the future, it is not impossible to imagine that one day our descendants may stand on the threshold of time itself, ready to step beyond the boundaries we once thought unbreakable. Perhaps they will look back at us, their ancestors who first told bedtime stories of time machines, who first whispered of paradoxes and possibilities, and they will smile knowing that we were the ones who first dared to dream. When we think of time travel in the far future, it is easy to picture fantastical machines, glowing tunnels, or clocks that spin backward. But the true possibilities may arise not from fantasy, but from the very laws of physics themselves, laws that we are only beginning to understand. Einstein's relativity already gives us a kind of time travel. If a ship could approach the speed of light, its passengers would journey into the future of the universe. Imagine a vessel departing Earth in the year 2500. Its engines burn with power, carrying it to 99.9% of light speed. For those inside, only 10 years might pass. But when they return, 1,000 years could have swept across Earth. To the traveler, it would feel like stepping through a doorway, leaving one age and arriving in another. They would carry youth into a future they never lived. This is not fantasy. It is a direct mathematical prediction, as real as the orbit of planets or the fall of an apple. The challenge is not whether time behaves this way, but whether we can build ships to reach such speeds. There may be other, stranger paths as well. Remember how black holes bend time? If we could one day approach them safely, we might use their gravity as a tool, a way of slowing our own clocks compared to the rest of the universe. A colony orbiting near a massive black hole might live centuries into the future of Earth, aging far more slowly than those who stayed behind. Of course, the dangers are immense. Radiation, tidal forces, the risk of falling past the event horizon. But as technology grows, perhaps humanity will find a way to dance at the edge of these giants, using their gravity as a natural time machine. And then there is the dream of wormholes, theoretical bridges, tunnels linking distant points in space and time. In theory, a wormhole could connect one moment to another, perhaps even allowing travel backward as well as forward. To hold such a passage open, however, physics demands something extraordinary, a kind of exotic matter with negative energy. We do not yet know if such matter exists, but quantum physics hints that the vacuum of space itself holds strange energies, flickering, uncertain, full of possibilities. If one day we learn to shape these energies, wormholes may become not just stories, but tools, gateways built by human hands, linking centuries and galaxies together. Quantum physics also suggests subtle possibilities. At the smallest scales, time does not flow smoothly. It flickers, uncertain, like light seen through rippling water. Some scientists wonder if quantum entanglement, the strange connection that links particles across distance, might one day allow communication across time as well as space. Could a signal be sent backward, whispering from tomorrow into today? For now, this remains deeply speculative, but it reminds us that the future of time travel may not be about great machines or vast energies. It may be about the smallest details of the universe, tiny, delicate threads of reality we have not yet learned to weave. Behind all of these theories lies something deeply human. Our longing to travel in time is not only about science. It is about memory, about loss, about curiosity. We wish we could step back to see loved ones once more. We wish we could leap ahead to know what becomes of our world. We wish, simply, to know that time does not always take without giving back. And so the pursuit of time travel is not only a scientific journey, it is also a spiritual one. It asks, what does it mean to live in the present? What would it mean if the present were not the only place we could stand? As you listen tonight, let yourself imagine what it might feel like to step into such a future. Would you choose to leap forward, to see Earth 1,000 years from now, to meet the descendants of your descendants? Or would you remain anchored in your own time, treasuring the moments that are yours, even if they slip away more quickly than you wish? There is no answer, only reflection. For whether or not we master time travel, we are already travelers. Each breath, each heartbeat carries us forward into the next second, the next day, the next year, and perhaps this gentle, inevitable journey is itself the purest form of time travel we will ever know. As we arrive at the final part of our reflection, let us linger on what time travel truly means, not only for science, but for the heart, for humanity, for our future as a species drifting among the stars. The future of time travel is, in many ways, the future of human curiosity. Every discovery we have made, from fire to the telescope, from flight to quantum physics, began as a dream, a whisper, a hope. Time travel, too, begins here, in our imagination. Perhaps, centuries from now, humans will walk among the stars. Perhaps they will master speed so close to light that decades on Earth pass in the blink of their eyes. Perhaps they will build stations near black holes, turning gravity into a clock that ticks differently from all others. And maybe, just maybe, they will find ways to fold the fabric of the universe, to build bridges across centuries, to step across time as easily as we now step across oceans. The future of time travel is not simply about science. It is about courage. It is about the willingness to look at the impossible and say, someday. But every great power comes with responsibility. If humanity gains the ability to move freely through time, we must ask not only can we, but should we? What would it mean if we could look into the past and change it? Would history remain stable, or would it splinter into infinite possibilities? Would our choices ripple outward, changing not only the lives of others, but erasing the very steps that led us here? And what of the future? If we could see what is to come, will we still feel free, or will we live only as actors in a play whose ending has already been written? Science tells us that time may resist such tampering, that paradoxes guard the past, and uncertainty guards the future. Yet, wisdom tells us that even if the doors of time could be opened, we must tread carefully, for time is not only a dimension, it is the fabric of our lives, the canvas upon which every memory, every love, every moment is painted. And so, as we dream of tomorrow's time machines, let us not forget the quiet wonder of the present moment. For even without a vessel, without a wormhole, without the speed of light, we are already time travelers. Each sunrise carries us forward. Each memory carries us back. Each heartbeat is both a clock and a journey. When you close your eyes tonight, you are stepping gently into the future. And it reminds us gently that even as we dream of centuries yet to come, we must also cherish the fragile present, for it is the only place where we truly live. And now, dear traveler, we reach the end of our journey through the science of time travel. We have wandered through mysteries and theories, from Einstein's relativity to wormholes, from paradoxes to possibilities, from the past we cannot change, to the future that waits like a distant shore. May these reflections bring you peace. May they remind you that even within the quiet of your own breath, you are part of the great flow of time. May you rest tonight with wonder in your heart, dreaming of galaxies, of clocks, of horizons yet unseen. And as you drift softly into sleep, know that you, too, are a traveler in time, moving gently, beautifully into tomorrow. Good night, dear friend, and goodbye,